Here we have AP calculus AB problem. Okay, let's go to the question. Here we have to evaluate this definite integral, that is integral e to e square dx over x times ln x. Okay, now what I'm going to do is I'm going to evaluate this integral as an indefinite integral, that is without these limits. Once I get the result of the indefinite integral, then I'll apply the given limits over here, that is e and e square. Okay, now let me take this one as an indefinite integral, that is integral dx over x times ln x. Okay, now what we can do is we can split up the stuff we have over here. When I split up the stuff we have over here, then I'm getting 1 over ln x times 1 over x times dx. So I just write this dx over here, and I write this x in denominator separately as 1 over x. Then I have 1 over ln x. So because if I split up the stuff we have over here, like what I've written over here, I can use the method of substitution, because I know that the derivative of the natural logarithm of x is 1 over x. So in this integrand, the derivative of a particular part is multiplied in the integrand itself. So whenever the derivative of a particular part of the integrand is multiplied in the integrand itself, what we can do is we can use the method of substitution. That is, we have to substitute a new variable for the part for which we have derivative. Here we have derivative for ln x, that's 1 over x. So now we have to substitute a new variable u for this ln x. Let me do it. Let u equals to ln x. Okay, now since I have substituted a new variable u for ln x, I have to change this complete integration to the new variable u. When I change this complete integration to the new variable u, at the place of dx, I must be getting du, so that I'll be able to integrate with respect to u. Okay, at the place of dx, if I want to get du, what should I do with this u? I have to find derivative. So here u is a function of x. Since u is a function of x, we can find derivative on both sides with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. On the right side, when I find derivative of this ln x, I'm just getting 1 over x. Okay, now let me multiply both sides by dx to get up this denominator dx, so that I can solve for du. So here this dx will cancel out. I'm getting du equals to 1 over x times dx. Okay, now what I can do is I can plug in the stuff what we have discussed over here in this integration, that is integral 1 over, for this natural logarithm of x, we can plug in u, and for this 1 over x dx, I can plug in du. Okay, let me write over here. Okay, we know that integral 1 over x dx, what is the integration of 1 over x dx? We know that very well, it's ln x. The same stuff over here, instead of x, we just have u. So what is the integration of 1 over u? Du, that is ln u positive c, because it's an indefinite integral. So whenever we evaluate indefinite integral to the result of the integration, we must add the constant of integration c. Okay, actually u is a variable taken by it was taken by us. It has to be replaced by the original stuff, that is ln x. Then I'm getting ln of ln x positive c. So this ln of ln x is the result of this integration. So now we can consider this definite integral. In this definite integral, we can write this result ln of ln x along with the limits what we have over here. Okay, let me erase all the stuff and continue the problem. Okay, so let me write the result of this integral, that is ln of ln x. For this result, now I'm going to apply the limits. The lower limit is e and upper limit is e square. Okay, now in this result, we have to plug in the upper limit e square for x over here. Let me do it. Then I'm getting ln of ln e square. Now I have to take negative. In the same result for x, I have to plug in the lower limit. Then I'm getting ln of ln e. Then I'm getting ln of, okay, here the argument is a power. Whenever the argument of a logarithm is a power, we can move the exponent in front of the logarithm, and it will be multiplied by the logarithm. So here the exponent 2 can be moved in front of the logarithm over here. Then I'm getting 2 times ln e negative ln. Actually, ln represents a natural logarithm, and always the base of a natural logarithm is e. Usually we don't mention, even if you don't mention, everyone can understand when I use the spelling ln, it's a natural logarithm and its base is e. So here the argument over here is e. So in a logarithm, if the argument and base are equal, then the value of such logarithm is 1. So the value of this logarithm is 1, because it's a natural logarithm, its base is e. So the base and argument are equal, the value of this logarithm is 1. Let me do it, ln times, ln of 2 times. So here the value of this ln e is also 1, because here it's a natural logarithm, its base is e, argument and base are equal. So the value of this logarithm is 1, that is 2 times 1 negative. Here logarithm of 1. For any logarithm, if the argument is 1, its value is 0. Not only for natural logarithm, even for common logarithm or any logarithm. If the argument over here is 1, its value is 0. Then we get ln. So 2 times 1 is just 2. ln2 negative 0. We don't have to write this negative 0. Okay, now I just evaluated the given definite integral. So its value equals to ln2. We find this ln2 in answer choice D. The correct answer choice for this question is D.